Sir, is it audible, sir?
Yes, sir. Your voice is audible.
Sir.
So, shall we start the class, sir? It's 2:10.
Yes, sir, you can start. Sir, so welcome to the fifth day of our online PDP on IoT. Okay, so without further any instructions, let us hand the session to our speaker. So he'll guide us through that next segment. Sir, please carry on, sir.
Yes, sir.
Yes, sir. Yes.
So, good afternoon to all the faculty and students who are participating in this PDP program and on the IoT subject. So, we have been performing different types of tasks, and we have been doing them in the practical session, as well as we have seen the outputs in the different kinds of websites, and we have seen the output through the mobile application as well, like GSM modules, GPS. Have done many IoT related things like internet related modules we have completed with ESP32 and MQTT protocol with GSM. And we have seen 80 commands, how to communicate with the hardware we have seen. So we have done most of the things related to IoT, which requires as a basics and as well as the uh, higher level things. Okay, so as we have discussed in the yesterday's class that we have to complete LoRa communication with our embedded board and as well as the Bluetooth communication. So yesterday we have done hardware related thing, like we have connected the Bluetooth module, and we have done the coding as well. I have explained you about the coding as well. So first we'll complete the coding LoRa communication part, and then we'll move on to Bluetooth. At the end of the class, we'll see the output of Bluetooth. So the first task for today is communicating through LoRa module using Arduino or else ESP32. So I have given you the hardware which requires for completion of this task in the yesterday's only. So we'll just start our session regarding uh, LoRa communication. So first of all, in the first day of the class only, I have told you what is LoRa module in the session. So LoRa is a radio communication module that works on the 433 megahertz frequency. Okay, so we have seen some features and specifications of that module as well. So we have seen it works on 3.3 voltage level and the frequency is 433, or else we'll have a 915 megahertz available in the market as well. And the distance range is about 5 to 20 kilometers based on the uh, antenna size. Okay, so every radio communication, if you want higher distances, you need to connect the antenna which is having higher length and as well as a higher power. You have to provide the higher power as well when you're referring to high distance ranges in the radio communication. So we have seen all the wireless communications like Bluetooth, Wi-Fi, internet, and GSM, and now we are seeing radio communication. So under the radio communication, we have seen we have listed out the what are the available modules as well, like ZigBee, NRF, LoRa, and normal RF433 module. So like this, we have listed out and we have seen the features. So among them, we have now interfacing LoRa module here. So the module specifications I will just display on the screen. Just a minute. I'll just start to share the screen. Yes. So this is the module we are going to interface now, S61278 LoRa module, which works on the frequency of 4.3 megahertz, and the distance range is up to 15 kilometers, I mean communication range, and the frequency range is 433. And this module costs around 384 to 400 in the market, and it is very affordable when you compare with other models with higher efficiency and higher distance ranges. Okay, so when you are preferring a duplex radio communication, you have to choose this one as a top priority, because this module works in two-way communication. Like duplex means you can send the data and you can receive the data at a time by using one LoRa module and as well as the the distance range also very high when you compare with other models with higher cost, and the data speed also very high, that is 300 bytes per second, and then the frequency range also very easy to the frequency range is very easy to communicate. And that's it. This is about the features of this LoRa module, and we can see the power supply specifications as well here. So this module works on 3.3 volts. Okay, 1.8 to 3.7 volts we can give. This is a working voltage. So if you give more than this voltage, the module will burns out. Or else if you give less than this voltage, the module won't power on. Okay, so this is about specifications. And when you are interfacing any module, I have told you in the previous class as well, we have to go through the GPIO of those particular module, like LoRa. We are interfacing LoRa now. So we have to go to the pin out of that LoRa, and then we have to connect that LoRa with our microcontroller. So in our case, our microcontroller it is Arduino or else ESP32. So I will just show you the GPIO and as well as the schematic, and then we will move on to coding part, and then we will move on to the output part. We will see the output. We will implement the thing in the we'll see the output in the video session. Okay, so I'll just so I have to mention the module name SX127. This module comes up with SPI communication. So I have told you some hardware communication protocols before. I'll just give you a brief regarding hardware communication protocols. So this is GPIO of our LoRa module. So previously we have discussed what are the hardware communication protocols are there. Okay, so what are the hardware communication protocols we have discussed? The first one is UART, means universal asynchronous receiving and transmitting. UART, and then SPI we have seen SPI and I2C. Then digital communication. Digital communication also refers to hardware communication protocol with respect to microcontroller. Digital and then analog. That's it. So we have seen LAN and CAN as well. So I will discuss those boards won't comes under this embedded systems. I will just concentrate on SPI communication, which is going to we are going to interface now with the LoRa module. So SPI communication is which we are going to use for the hardware communication protocol for LoRa module. So I will just give you the brief information about this protocol because we are going to use that one. So SPI is nothing but serial peripheral interface. Serial peripheral. Yes, very good.
ఇక్కడ మనం అంటే పిల్లల దగ్గర ఏం చేయించే అంతనే ఉండదు కానీ మనం ఏమైనా నేర్చుకోవచ్చు ఆయన దగ్గర వచ్చి సిఎస్డి పిల్లలు వాళ్ళు వస్తారు వీడు వాళ్ళ నుంచి ఏమైనా మంచిగా చేసుకోవచ్చు అంటే
Mute yourself.
వాళ్ళంతా ఏదో సాఫ్ట్వేర్ చేస్తారు.
Creating noise. Serial peripheral interface. So here SPI refers to serial peripheral interface, where this particular communication protocol has its own fixed communication pins. Okay, so we'll see what are those. So in the UART we have seen TX and RX pins there, TX1 and RX. So we have seen this, and in the SPI communication we have to use 4 communication pins. Those are MOS5, 4 most important pins, MISO, and then SCK, and then RST, So these and then along with this enable pin. Okay, so these 5 pins are very important in SPI communication. So along with these 5 pins, we will be having power supply pins as well. That is VCC and ground. For LoRa model, it is 3.3 volts. Okay, so MOSI means master out, and slave in. Okay, so when you're interfacing your LoRa module with any kind of microcontroller, so here the Arduino and LoRa module will act as a master and slave. Means one in sometimes Arduino acts as a master, and in sometimes LoRa acts as a master. Okay, so based on the module which is sending data and which is receiving data, so the sending and data module will be act as a master, and receiving and module will be act as a slave module. So based on this notation, we have given a name as master in and master out. Okay, so here, so master out slave in indicates pin MOSA, and then master in slave out. So if we consider Arduino as master, in this case, the master will receive the data because master is in, and if you consider the LoRa module as slave, so in this case, the LoRa is giving out the data. Means the Arduino can receive the data by using these pins. Okay, and the clock, serial clock. So every microcontroller is every embedded boards needs a clock pulse to work. Okay, so every whenever you give the clock pulse, the module will start to receive the data or send the data. Okay, it depends on the clock in which mode you are giving. Okay, so this is serial clock. That's it, and then reset. Reset. It's a pin that will be used to reset the board and enable. So enable will enable the our LoRa module. So these are the total pinodes that will be there in the our LoRa modules GPIO. And along with this, we'll be having some more pins as well. That is DIO 0 and DIO will be having 0 to 4 GPIO pins, which we are not going to use them as of now because we are not dealing with the multiple channels here. Okay, so if you want to create multiple channels in LoRa communication, we can use those pins. I will tell you what are those. On the GPIO, you can see. So here you can see this is the LoRa module, and we have DIO 0 to DIO 5 pins are there, and among this we are using only DIO 0 here. Okay, so these pins are left not connected because we are not using any multiple channels here. Remember that. And then that's it. So this is the DIO0 we are going to use, and these are the pins that we are going to use as an SPI communication protocol now. Okay, so we have been completing all the hardware communication protocols. We have taken every example, like for analog data, we have taken my smoke sensor. For digital data, we have taken DHT sensor, and along with that, we have seen some other sensors like IR sensor and all those things we have seen. And then I2C. For I2C, we have seen uh, for I2C communication, I think we have done one component. Anyone remember? Okay. So if you are not completed this I2C based communication, we'll do this today because we have to complete LCD display as well with Bluetooth module. Okay. So please concentrate on only this topic, that is SPI communication with LoRa. Okay. So first of all, we have to connect all these pins like MOS, MISO, SCK, RST, enable DIO. So we'll just connect all of these pins with our microcontroller, and we. So this is the Arduino Nano, and this is a LoRa module. And I told you that keep ready the total hardware that required for this task to complete. And with me, I have ESP32 and as well as the Arduino. So I'm going to connect both of them modules to make communication the LoRa communication, LoRa ports. So this is about schematic and GPIO and specifications. And after completing this topic, we'll move on to coding part. So first we'll see the coding part because we will have two parts of code here. So one will act as a sender and another one will act as a receiver, and as well as a vice versa because it's a duplex mode. Okay. So this is the
Hello, sir.
Hello.
Hello, sir. Yes, sir.
Anyone confirm whether my voice is audible or not?
Now it's audible, sir.
Fine, thank you. So we have been discussing about the coding part regarding this LoRa communication. So if you are able to do this, implement this LoRa communication in the electronics, you will be able to complete all the radio-based communications in the IoT sector. Because this LoRa is a very complicated thing when you are compared with other radio communications modules. Okay, so that's why I have selected this module to teach you in this 5 days session. So we'll just proceed to coding part. So yeah, I think the coding part, coding screen is visible on the screen. So after after completion of this discussion regarding coding, we'll move on to video session where we can see the connections and as well as the output. So here, as we have been discussing about the libraries or else header files for every modules or else objects. So in this code also we need two library header files. Those are nothing but SPI and as well as LoRa. Okay, so SPI library will enable the SPI communications. Okay, so serial peripheral interface. So for that communication, we need the library named SPI.h. So I have already downloaded this library and included this one. So and then LoRa.h. So this library will be used to make communication with the LoRa board. So for that thing, we need this module and it will simplify our coding part. And then we can see the two ports of this duplex mode transmit and receive will be looks like similar. Okay, so we'll just first concentrate on first one and then we'll see the second one as well because it will get to understand easily. So this is about pins for the our LoRa communication. So among these, we have to define manually 3 pins. Okay, so here we have totally 5 pins. Out of those 5 pins, we can define manually these 3 pins only, and remaining 2 or 3 pins are already defaultly defined in the this SPI communication mode. Okay, so these pins can be customized by the user. Okay, so I will tell you what are those pins. First one, the NSS, RST, and DIO0. Because this NSS, RST, and DIO0, you can see on this pinout here. So here we can see this is the NSS, which is also known as enable. Okay, so previously we have discussed about enable pin. So NSS is nothing but enable pin only. It will enable this LoRa board. And then DAO0, this pin can be modified by the user. You can change the pin number that can be done in the coding part. Okay, and then one more pin, that is RST. So this RST pin also we can change, reset. RST is nothing but reset. So that's I have done in this code. Okay, so I have defined the RST pin as 15 and NSS pin as 5 and the DAO0 as 2. And the people who are using Arduino board or Arduino Nano or Arduino Uno, you can select the pin numbers according to this image. Okay, I will write it over here as well. So pin number 9 as reset and pin number 2 as DIO. Reset, you can use 9 for Arduino. In my case, I'm using ESP32 with me. And for Arduino, it is pin number 9. That's it. Okay, and NSS and DIO0 will be same as it is. Okay. So remaining pins will be already defaultly defined with the library. That's it. So this is about defining pin configurations for the our SP and LoRa communication. And then what we are going to do in this code. Okay, so first with this LoRa communication, what we are going to do? We are just going to transmit the data. Okay, so we'll just send a some character or else hello world, hello
NSS yellow Vardhaman like that. So we can send some text and we'll receive there. Okay, so we'll just go to the code here. So first, after defining the codes, after defining the pins, we have defined some variables here. Okay, these are the variable parts. We know that totally there are 4 sections. That is where library inclusion and variable creation section, and then void setup, and then while loop, and then user defined method. Okay, so this is user defined method here. Is defined by us. Okay, so we'll go through one by one. So this is the variable declaration section, which will utilize useful for my further part. Okay, so here these are the variables that for storing sensor data, or else storing in string, or else triggering any relay. Okay, with this code you can control the load as well using LoRa. Okay, so I will share you this code through the protected text website, where we have been sharing the codes and links there. So I'll put there this code. You can implement this code with your own hardware along with me, as well as after completion of class as well. So you can copy the code and you can upload the code. This will control the loads and sends the data at a time. After completion, we will put in code there. And then this is about variable declaration, and then this is about address declaration for the our LoRa module. Okay, so here we are using 2 LoRa modules. So for one LoRa module, I have given the name as 0 cross FF, and then destination address as 0 cross DB. So which will define the 2 LoRa modules here. So through this address bit only, we have to communicate. Okay, we have to identify which module this is. Okay, and then so that's it about the variable creation. And then in the setup code, we have begin the LoRa board here, that is LoRa.set pins NSS, RST, and DIO. So this command will enable will start begins the communication with the LoRa board. And after this this begin, so we can see here if there is any error, it will be in the LoRa init failed, and if there is no error in beginning the LoRa module, it will be in the LoRa init succeeded. Okay, so this is about beginning the LoRa module in duplex mode. Okay, so if we just use the LoRa.begin after the command of setting pins, the module will be begin. So we have to use this command in the setup only, because it has to begin only once. We don't need that to run every time. Okay, so this is about setup code, and after this we have defined some relays also here. So the relay 1 is nothing but pin number something 12. Okay, so 12 is I have defined it as relay. So I have taken some more pins as well. If you need, you can declare more pins as well if you want to control more loads. Okay, so and after that we move on to while loop here. So here what we are doing, we are yes. So this is the command that will send the data to our receiving mode, means slave. Okay, so if you consider this code as a master, so this will be send the data whenever there is available receiving module. Okay, so this is the command you can see on receive LoRa.parse packet. So this is for receiving data, and yes. So to send the message, you have to use this method, void send message I have declared here. And then to receive the message, you have to use this method. So this method is defined by me, which have some definition inside this loop. Okay, so we'll go through them and we'll see one by one. Please mute yourself. Someone creating noise. So yes. So this is a command to receive the data on receive LoRa.parse packet, and this is the code for reading the relay status. Okay, so here what we are sending is we are sending relays data, which switch has to be turned on or which switch has to be turned off. Just we are sending ones and zeros. Okay, so if you send 1, the relay will be turned on. If you send 0, the relay will be turned off. So here what we are checking, whether the data is transferring or not, whether it is sending 1 or whether it is sending 0. So at the end, we will see the data which is transmitting through the LoRa modules. So at that time, you will get clarity over there. Okay. So that's it about this code regarding LoRa module 1, and we'll see LoRa module 2. So this also board that is connected to same ESP32. So the pin configuration will be same. That NSS to 5 and RST to 15 and DA0 to 2. And for Arduino, this in number 9. Okay, so that's it. And yes, so in the same way, we have declared the variables and pins for the relays, and have defined some variables for the communication as well here. And the same address which we have defined over there in that code, we have to use the same address bits, that is 0 cross DB and 0 cross FF. So this address bit indicates the X code. Okay, so it's the hexadecimal number 0 cross FF and 0 cross DB. And then the setup code. So in this also, we have to begin the LoRa module by using the same commands which we have used in that code. So I have told you that the coding will be similarly for the sending and receiving end. Some 2 or 3 lines of code will be different. Okay, so 90% of the code will be same. Yeah. This is about setup code, and this is the loop code. Here, what we have to do, we have to send the data or else receive the data. So here we are sending the data by using send message command. You can see here. So send message. So message refers to the message which has to include all the sensor data which you are sending. Okay. So here I am sending message sensor 1, sensor 2, sensor 3, sensor 4. So here what this line indicates is it is combining all the sensor data with a comma. Okay. So this place indicates combining a string. Okay. So with separator of comma. So every every addition includes a comma separator which will be used to separate the our sensor data. Okay, so at the receiving end, it has to know where it has to separate. So I have placed comma over here, and then in the receiving end, I can know after the comma, I have to read it as a new data. After every comma, it has to be a new data. Okay, so that's why I can store in a new variable. So yes, so this is about sending data using send message method. So in the send message method, what is there? We'll see. So in the send message method, this is the send message method definition. Okay. So in this method, LoRa.begin packet, LoRa.write, LoRa.write, LoRa.write. So means this packet, this command will begin the packet to send the data. Okay. So in LoRa communication, will communicate through the packets. Okay. So packet is nothing but every time it has to send the data. In that packet, we'll put all the data that we have to send, and we'll send that packet through the LoRa. Means in this line indicates the packet. Okay, so we are packing all the sensor data into one string. Okay, so we are just packing all the data into one string, which will indicate a packet. Okay, so that packet we have begin, and after that we have to write the data by using LoRa.write command. So here we have given the LoRa.write destination address, local address, means this LoRa module address, and then message count, and then the length of the outgoing message. Okay, so for that thing we have to use this command as outgoing length. So whatever the data is going out through this LoRa module, the length will be given here. Okay, and then LoRa.print, that will send the data that is provided in this parameter braces. Okay, so whatever you give in this braces, that is outgoing, so it will send. So in place of outgoing, you have placed my message, so which will include all the sensor data. It will send the message by using this LoRa.print command. Okay, so to send one packet of data, we need to use all these commands every time. So to simplify that command, I have used external method which is defined by me and have placed over there. And after that, after sending every data, every packet, we have to end that packet. Okay, so LoRa will still wait if you don't use this command for the incoming data. So that's why we need to end that packet by using LoRa.end packet command. Okay, so this is about sending the data, and this LoRa module is parallelly receiving the data as well. So how it is receiving, we'll see. This is on receive command. So this void on receive command will indicate you how it is receiving data and how it is storing data. So here this is the main command. One command that is enough to understand this total code. Okay. So this incoming is equal to char LoRa.read. Okay. So it is combining all the character data that is receiving to the LoRa, and it is reading, it is saving it in the incoming character variable. So it will this plus is equal to indicate that every time it reads one data, one byte, it will adds it to incoming variable. So incoming is nothing but it's a string that will add up on by using LoRa input data. Okay, so whenever LoRa is available, while LoRa data available means whenever the LoRa is available with the data, it will read the data and it will store it in the incoming string. Okay, and then that's it. And this total remaining data is no need of any explanation, because it's just about supporting lines of code, that is incoming length. This is for measuring the incoming length. Whatever the data it is getting, it has to measure the length, and there's the variable that I have declared for reading the data. Okay. So first, we have read the reception data, and then the sender address, and then sender ID, message ID, and then sender length. So it is like follows, like I'll show you. So it is reading one by one bytes. So every time it will read the 1 byte of data. So here we are sending data byte by byte. You can see here LoRa dot write. So the first we are sending the destination address. So in this receiving command, we are reading the reception address. Means uh, it's just reading the data whatever you are sending byte by byte. Okay, so first byte destination address, it is reading the reception address, and the second byte it is sender address, it is local address. Okay, so whatever you are sending over here, it is reading byte by byte. Okay, so every time you use this LoRa.read command, it will read you the 1 byte of data, that is that you are sending. Okay, so after completion of all these 4 bytes of data, okay, so after completion of these 4 bytes of data, you have to read the our original data, that is outgoing message. Okay, so for that thing, I'm using while command here. Okay, so after completing 4 lines of bytes, I'm using while command here. So this will read you the all the available data in this string. Okay, so after coming the data into this string, you have to separate with the commas. Okay, so after that we can print the data in a serial monitor. Okay, so that's it about this sending and data and receiving and data codes. So if anyone have any queries or doubts, you can let me know, or else we'll move on to our practical session, and we'll connect all the hardware that we have been discussing, and we'll see the output. So with me, I have Arduino and as well as the ESP32. I will show you the hardware connections with both the modules. So I'll just connect the connections with Arduino, and then we'll see the connections of ESP32. So the ones who are having hardware with you, you can start to connect all the hardware. So please make sure that you have all the hardware with you right now. So give me a minute of time. I will just start the video session. So this is the Arduino Nano that we have seen in the previous class as well in the Bluetooth communication. So this is Arduino Nano, and then this is the LoRa module that we have been discussing. Okay, I'll just pin my account to show the video feed. Okay, this is Arduino Nano, and this is the LoRa module, and which we have seen the schematic. So we'll follow the schematic circuit diagram and we'll connect one by one. Okay, so in case of Arduino Nano, it is this is a schematic. How to follow this? Fine, I will guide you through the video feed on how to connect these pins one by one. So first connect 3.3 volts and ground as per the circuit diagram. So just you will find the 3.3 volts pin in the Arduino Nano, and you will find the 3.3 V pin in the LoRa module as well. So just connect them. This is the Arduino Nano. Here you can see the 3.3 volts label pin here. Besides this USB pin, this is a 3.3 volts pin. I'll just connect orange color pin to this one. So the connections for sending end and receiving end will be same. So I have just connected 3.3 volts and ground pin to the Arduino, and I will connect them with our LoRa module. There are totally, I think, approximately 5 or 6 pins are there, including the power supply pins. So I just connected the power supply pins of the Arduino to our LoRa board. Okay.
and then we have to connect the data pins. So data pins, what are the data pins here over there in the SP communication? First one is the MOSI. Okay, so MOSI and MISO should be connected to the MOSI and MISO respectively to the Arduino Nano board. Okay, so according to schematic, the MOSI should be connected to the pin number D11. Okay, I'll just connect that. D11. So this is the D11 pin. Left side of the USB, you can find it. D11, I'm connecting it to MOSI of the our LoRa module. And then after I will connect the MISO. So MISO of the our LoRa module. MISO. And then it has to be connected to D12. We'll verify through the schematic as well. So it has to be connected to D12. MISO should be connected to D12 and SCK should be connected to D13. So SCK to D13. So this is the D13. And then it has to be connected to SCK of the our LoRa module. So that's it regarding this MOS and MISO and SCK, and then we have to connect RST and DIO 0 pins. So I will take RST and I will connect it to pin number 9. And then DIO 0 to pin number 2. We just take one more example. Pin number 2 is to be connected to. So this is the pin number 2 I'm taking. And then it has to be connected to DIO 0. So this is the connection that we have done for the Arduino and LoRa. Okay, so anyone have any doubts regarding these schematic connections? I've just followed the schematic that which I have shown you earlier. Okay, so this is the schematic that we have completed, and this is Arduino Nano and LoRa connection. Fine. So for sending end and receiving end, the connection should be same. There is no connection is different when you compare with sending and receiving. Okay, so all the connections are identical. So we'll just copy and paste. We can just copy and paste the connections for sending end and receiving end. So for now, I have connection done with the ESP32 and LoRa to make it LoRa gateway. So I will just show them. So this is the one LoRa node. This is the second LoRa node. I've already done the connections for sending and receiving end data. Okay, so this is about ESP32. So if you can, if you have ESP32 with you, you can follow this schematic. So whatever the model you can use, but in case of ESP32, if you can read the data from LoRa module, you can send the data to the IoT gateway as well. Okay, so in the yesterday's class or previous yesterday's class, we have seen sending data through ESP32 to any database like ThinkSpeak, Firebase database. We have seen. So in that case, what will happen if you get this data from one LoRa module to another LoRa module? I mean, if you can send, consider an area, a remote area which is not having any internet connectivity around 20 kilometers of a radius. Okay, so in that case, what will happens? You have to install radio communication to transmit the data. Okay, so it will depends on different ranges of frequency like 433, 915, 2.4, 5 gigahertz like this. So you have to prefer those kind of radio communication. So we'll replace those radio communication with this LoRa modules, and we'll send this data over more than 10 kilometers range, and we can extend the range by using extenders as well. So what will happens? I'll just explain you this part of thing by using an image block diagram here.
So consider this as a one LoRa set. So when I refer to LoRa set, please include the LoRa module and as well as the microcontroller here. Okay, so this is the one LoRa set. LoRa set 1, and then I will consider one more LoRa set. Consider it as a LoRa set 1, LoRa set 2. LoRa set. So in this case, we have only two LoRa's. Okay, in our case, we have only two LoRa modules connected with our ESP32 or else whatever audio board. Okay, so in this case, if you want to extend the range, okay, you can use one more LoRa set with your microcontroller. So in this case, what will happen? This first one will send the data to the LoRa set 2, and the LoRa set 2 will send the data to our LoRa set 3. So this we can call them as a nodes. Okay. Yes, so we can call them as a node 1, node 2, and node 3. Okay. Node 1, node 2, and node 3. Okay, so here every node indicates a LoRa set. So in this case, if you can send data over 10 kilometers by using so I will consider this distance range as 10 kilometers, 10 km. Okay, so in this case, the required range is 20 kilometers. What we'll do? We'll add one more LoRa node, and which can send the data over 10 kilometers of range. So in this case, what will happen? Our required output will be done. Okay, so here now we can see the total range is 20 kilometers. So what we have done? We have just connected a LoRa repeater. Okay, so we can call it as a LoRa repeaters. This kind of methodology we can call LoRa repeaters. It will repeat the data that is transmitting over this LoRa communication. Okay, so for now we'll use these two boards to send the data. So I'm referring to an example where a remote area that is not having any internet connectivity. So in that case, you can use this kind of repeaters to send the data over more than 20 kilometers. And after that, if you have network there, so I'm using anyway, I'm using ESP32 here. Okay, so my control board is ESP32. So in that case, if you give connectivity, so after 20 kilometers, you can give connectivity because we have connectivity there. So I will just turn on my hotspot and it will send the data to our IoT gateway. So where once the device is connected to internet, it can send the data over the world. So wherever the world, you can see the data after getting connected to internet. So that's the advantage of this ESP32 board. So I'll just proceed with ESP32. If you are having Arduino boards, no worries, you can follow the same code. Just you have to change this pin number RST, that is to be connected to 9, and in my case it is 15 in the case of ESP32. In case of Arduino, it is 9. So if you change this one pin number, the total schematic and coding will be same. Yes. So that's it about this repeater and IoT gateway part. I mean, if you connect IoT here, I will now note it as a IoT gateway. So this is the advantage of our ESP32. So if you connect IoT here, it can send the data to over the cloud. And okay, I'll just explain you the connections. So here I have connected the same schematic which I have shown you before. So this is schematic I have followed. Okay, so this is a LoRa module and DIO0 or RST, NSS, MOSI, MISO, SCK. I have followed the same connections. Okay. And that's it. If you are having any doubts regarding the schematic hardware connections with the ESP32 or this Arduino Nano, you can let me know. or else I will just power the boards and I will just upload the code, whatever we have been discussing, and we'll check the output. One second, I'm just powering up the boards.
Fine. I think my voice is audible to all of you.
Yes, sir, your voice is audible.
So I'm just powering up the two boards. I'll just start the video feed. Yes, so the boards are powered on and the communication also started to start between these two boards. Okay. So this is there is no connection in between these. These are the antennas. You can see to share the data to the LoRa communication. We'll check the output through the serial monitor. Yes. So this is a sender and receiver model that will transmitting data here. So as we can see here, this is the sending end part. Okay, so this is a serial monitor that indicates sending end part, which is sending 1, 1, 1, 1, and the receiving end is receiving the same data as 1, 1, 1, 1. So in some cases it is not receiving any data, so that's why it is printing zeros. Okay, so whenever it is receiving data, it is printing ones. Okay, so we'll just check whether the transmission is successful or not by interrupting this transmission end. Okay, so this is the receiving end. So I'll just disconnect the transmitting power supply. So I'll disconnect power supply for transmitting end here. So in the video feed also you can see I have removed the power supply for transmitting end so that the power supply, communication has been interrupted. So we will see whether we are getting the data or not. So yeah, we are not getting any data. You can see I will clear this output. So we are not getting any new text inputs or any data from the sending end. Okay. So just reconnect the power supply for sending end. We'll check the communication will restart or not.
So you just click reset button on the ESP32 both the boards. So yes, we started sending the data again. I will remove it. So the data stop again. Okay, so this is how the transmission and receiving end will be sends data. We will just try to change the sending end data. We'll change the one to some other data. Okay. This is the transmitter code here. I will just change this sensor one data to something else. I will replace it for number 4. I will replace this with number 5. Replace this with number 6 and 7. So this data we can use for turning on and turning off the loads. So we'll just upload the code again. Just in the port number here. I just upload the code and we'll wait for the code to upload. Yes, this is about sending and receiving data through the LoRa modules. And after this, we'll see the Bluetooth communication, and we'll end this session for today. And before going to end this session, we'll try to clarify our doubts during today's session. So I have just changed the coding part in the sending end, that 4, 5, 6, 7 it has to receive. As you can see, it is receiving 4, 5, 6, 7 over there. I opened both of them. Yes. So this is a sending end and this is a receiving end port. Okay. So here I'm getting some data that is 4, 5, 6, 7, which I have changed with one ESP32. Okay. I have only uploaded port to one ESP32, that is that has to be sent 4, 5, 6, 7. Okay. We'll just remove supply to the transmitting end. So receiving has stopped. That's it. This is about the communication between LoRa modules. And in the video feed, if you can see, some LED, blue color LED is blinking. So video feed, all of you can observe on the video feed. So when I interrupt the transmitting end, the blue color LED also stops to blink. Okay, so this is a, you can say this as a receiving end. I'll just remove the supply for transmitting end. So in this ESP32 also the LED stop to blink, means we are controlling an LED, onboard LED on the ESP32. Okay, so if I restart the communication, the LED will starts to blink again. Okay, so if I give power supply to this module, it is started to begin the blinking of LED in this module. Okay, if I remove supply again, same will happens. This is about LoRa communication. And fine, the communication has re-established again. So we will show you the hardware clearly.
So this is the LoRa 1 with the LoRa set 1. This is the LoRa set 2. It's connected. This with the and this one. This is the total set for communicating between two LoRa modules. And we'll just see the output of Bluetooth modules, which we have paused in the yesterday's class. I will just bring out them. Okay. So further thing, we need one more object, that is application. You can download the Bluetooth application that is named as a serial Bluetooth terminal in the Play Store. If you go to Play Store, you can find that application. That application we are going to use for the Bluetooth communication. So I'll just show you the hardware which I have connected. One minute. I'm just arranging the hardware. After this, we'll end the session for today. Yes. So I have connected Bluetooth module with Arduino Nano. This is the Bluetooth module which we have connected in the yesterday's class. So regarding hardware, we have done all the basic things. I have explained the schematic as well. So we'll start to communicate with this module through the mobile application. So for this thing, we need to pair with the Bluetooth module. So we have to pair as we pair the Bluetooth headset. In the same way, we have to pair by going into Bluetooth settings. We'll find the Bluetooth module name as HC05. We'll show you in the mobile as well. So this is the HC05 module name on the video. You can see. So I have to pair. We have to pair with this module, and after pairing, you ask the password. So you can enter the password as 1234 or else 4 zeros. So as you can see, I will show you through the video. So here the devices are listed, and this is the HC05. You have to select. I've selected HC05, and the password is 1234, and then enter. So the device will be paired with your phone, and then open serial Bluetooth terminal app. So this is the application. So here we have to go to devices on the left side menu bar, and then SC05, which we have just played. So we have to see the MAC ID as well. So the MAC ID of this Bluetooth module is 98A3. I'll just select that 98A3 module. This is the module, and they're just paid. So now what will I do? I will send some data from this mobile app, and we have to receive the data through the serial monitor. We'll check. Okay. So this is the code we have discussed yesterday class. Now I will send hi from the mobile. So on the screen you can see screen sharing. I have sent hi. It is received hi, and it is printing in the serial monitor. You send hello. You print whatever you are getting through the serial. Okay. So this is a UART communication. We have done GSM GPS based UART communication, and we have seen Bluetooth hardware connections for UART. Just we'll be having two pins, that is TX and RX pins. How to connect them as per the UART protocol, that is TX to RX and RX to TX cross connection. So if I send NSIC, yes. So this you can use this kind of communication for controlling any rovers, robots, or any kind of notice board, or else any kind of load control. Okay, so if you can implement this Bluetooth communication between you and your loads that you are using in your home, you can control them by using simple application. Okay, so you can use this Bluetooth for the load control as well. Okay, so I think I hope all the participants got the part of this UART communication as well as the SP communication with Bluetooth and LoRa communication respectively. So by this thing we can end this session for today, and I think if anyone having any queries, we'll discuss that thing as well. So please raise your hands if you are having any queries, and I will clear out all your doubts.
Dear participants, if you are having any doubts,
Let me know if you are having
you
any
are
doubts,
free to.
participants, and if you're not having any doubts, so we can close this session for today. So I have got the information that we have one more session for tomorrow as well. There is a possibility, I think. So if you are planning, we can have that session as well, and we'll implement the protest simulations and some other simulations in that session.
Okay, sir, I hope there are no doubts from the participants. So, on behalf of all the participants, I like to extend sincere vote of thanks for Dr. Prabhu Rajudi, sir. Thank you, sir. We will see you tomorrow for the next session. The participants can now leave the session if you are not having any doubt.
So we can end this session for today.
Yes, sir.
Anyone, please respond anyone so that we can end this session. And if anyone having queries, we can